Greetings, detectives. Mrs. McKay here, and we are going to work on clue 5 today out of case 8. So it's all about scatter plots and trend lines. So let's go ahead and start by filling in our learning target. I can make and describe a scatter plot. Make sure that you're writing this. And find trend lines. All right. Every time my hand touches my tablet, I make a mark somewhere. We're going to start quickly, though, by just reviewing something, because what we're going to do today is going to sound very familiar to you, all right? We did, in case 3, we did some linear regressions, where we had data, we had an X and a Y, we had a series, we had a table, and we plotted it in our Desmos calculator, and told it that we wanted a line of best fit. And the way that we did that was we said y1 is approximately mx1 plus b. And when we put that into Desmos, it took our table of values and it created a line of best fit. And it also gave us a correlation coefficient, which was r. And sometimes it would be like 0.93, or it might be negative 0.89. But the correlation coefficient told us how good of a best fit was it, because the closer that correlation coefficient was to 1 or negative 1 meant the closer our points were to the line that Desmos created. And we used that line to make predictions. We could predict the future. We did some population things, we did attendance of games, but we made predictions based on that line of best fit. So we're going to do the same thing, but this time we're not going to use Desmos. We're just going to look at some trends and make some observations. So we're going to start with study hours and SAT scores. So this is some data from, I don't know where it's from your book, that says when a student studied a certain number of hours, this was the score that they received. So some research was done, all right? So we're going to plot this. We're going to plot all of these points, but first we have to label our graph. So the bottom is going to be our hours, and because that's our independent variable, and then the score is what happens as a result of the studying. So we'll say scores are our dependent variable, or our y-axis. Now I've already put in the intervals, and earlier I noticed that I made a mistake. So I want you to take a look at my intervals of 0, 4, 6, 8, 10, 12, 14, 15, 16, 18, 20, 22, and tell me if you see a problem. Do you see any problems with my intervals that I've created? Yeah, I see a problem. I see from 0 to 4 is 4 points. From 4 to 6 is 2 points, 2 points, 2 points, 2 points, 1 point, 16, 18, 20. So I've made a total mess of this. So this should really be, if I'm going to, the intervals need to be the same. So I need them, and it looks like for the most part they are 2 points apart, except for this 15 and this 0. So what if I did a little changing? And I think I can do that here. So I'm going to actually erase this, and erase this, and erase this. And rewrite them, all right? So you do the same thing. Okay. So I didn't really need to erase my 0. My 0 was fine. I just needed to erase the 2, 4, 6, 8, 10, 12, 14. And I've rewritten it, so now my hours have even intervals. And we're going to go ahead and do some graphing. Now I want to make my screen a little bit bigger just so that I can actually see what I'm graphing. And yeah, that'll work. Okay, so my first hour of study was 1, and I got a score of 350. So 1 is going to be between 0 and 2, and 350 is going to be right about there. All right? 22. 22 hours, I get a score of 780. So that's going to be close to 800, maybe right about there. 12 hours is 600. You get the idea. Why don't you go ahead and fill this in? I'll pause it to save time. Okay, so here's my points, and hopefully yours look similar to mine and that neither one of us made a mistake. Now, what I want to do is I want to look and see if there's some kind of trend. Does this look like I could create a line of best fit? Remembering that a line of best fit needs to have most of your points or all of your points pretty close to your line, and that you have about the same number of points above the line as below the line. So can we create a line of best fit? I think we can. Let's try it. I have a very skinny line at the moment because I want to be able to move it around a little bit. What do you think? What does that look like? It looks like I've got this point is almost on the line. This point is on the line. These are close. So maybe we say 1, 2, 3, 4. Or 1, 2, 3, 4 here and 1, 2, 3 there. That looks pretty good. I could move it more like this if I wanted. Have it be more like that. The only one that's weird is this one right here, right? And I think that's an outlier. That's what I think. I think that one doesn't quite fit my line. So let me go back down so that we can look at more here. All right. So here's my line of best fit that I've created, my trend line. All right. So I've created a scatter plot. I've created a trend line, and I can tell that it's definitely a line. And then I want to look at whether I have a positive or a negative correlation. Now, positive would mean that my line is increasing. Negative would mean that my line is decreasing. So tell me, which do I have, positive or negative correlation? That's right, it's a positive correlation because I have a positive slope and an increasing line. Now, the next thing that I want to do is I want to be able to make some predictions, and that's what interpolation and extrapolation means. Interpolation means that I'm going to predict from within my range of data. So my data started at 1 hour and it went to 22, but I'm really not going to count that one because I feel like that's an outlier. I feel like that one doesn't really fit in my line. So it's just an unusual one. So I'm going to really say it's from 1 to 14. So anything that's from here to here is interpolation, meaning I could pick an amount. Like I could say, well, based on my line of best fit, what do I think my score would be if I studied for 6 hours? And I could look at my 6 hours, go up to my line of best fit, and I can see that it's right about here. And I could say, well, if I studied for 6 hours, or if a student studied for 6 hours, they might score a 500 on the SAT. Or I could say, what if they studied for 13 hours? I could look at 13, go up here, and guess, or make an extrapolation, that their score might be 700. Okay? So that's what interpolation means. I'm looking within the data. So I'm going to write right here, within. It's the in. Extrapolation means I'm going to look outside the data. I'm going to predict beyond my data points. So that means if I say that 14 is where I'm ending and not my 22, then beyond my data would be, what if I studied for 18 hours? Then I could say, oh, my score might be 850. Okay? So that's what interpolation and extrapolation mean. Now what I want us to do, so we'll say outside here. Okay? I want us to do another one. This time, we're going to be looking at antibiotics and how long they stay in your body. So, Antibiotics, when you take an antibiotic, after a period of time, it starts wearing out, and it's no longer, it gets removed from your body through your different systems. And so the amount goes down. So we're going to graph that. And this is in a particular antibiotic called antibiotic X. Okay? We don't know which one it is. So our time is the amount of time that it's been in the body. And that's going to be our independent variable. So we'll label our graph with hours. And then on the side, we'll say milligrams of antibiotic. Okay? Now let's go ahead and do some graphing. And again, I'm going to make this larger. And I'm going to say at 0 hours, meaning when I just get the antibiotic, I have 60 milligrams. At 6 hours, I have 36 milligrams. At 12 hours, 22 milligrams. And at 18 hours, I have 13 milligrams. So 18, right about there. Okay? Oops, that's not 18. Better do that right. 18 is right here. All right. You go ahead and finish it and come back and we'll compare. Okay. What'd you come up with? Do you see our trend, our data points? Now, my question to you is this a line or is it something else? It's something else, isn't it? What does it look like? Does it look like a function that we've studied? It looks like an exponential function to me, and I think if I kind of try to sketch something in between all of these, I would get an exponential function. I'm not very good at drawing curves, you can tell. All right. So I have an exponential function, and it's not a line. You can tell, because if I tried to draw a line, I would not be able to get my points on either side. Really, it's a curve. It's an exponential function. And I want to be able to decide whether it has a negative or positive correlation. What do you think? It's negative because everything's decreasing, right? And now let's do a little interpolation. That means I'm going to make an estimate. I'm going to estimate or predict what the amount of antibiotics would be in my body for a certain amount. So I'm going to pick 15. After 15 hours, what do you think the amount of antibiotics would be in my body? Well, just take a look at my graph. It's right about here. And that looks like it's maybe about 17 or 18, right? 17 or 18. So after 15 hours, I've got about 17 to 18 grams of antibiotic in my, milligrams of antibiotic in my system. And then the same thing, I could extrapolate and go even beyond, right? I could say, what about at 0.5 hours? I'm sorry, not at 0.5 hours, at, let's say, 50 hours. 50 hours, so like right here. Or 55 hours, right? 50 hours, maybe it's down to 0.5, right? If I could look at my graph really carefully, I might be able to make that estimation. So extrapolation is going beyond the data, and interpolation is inside the data. And that's pretty much all I have for us today. So go ahead and take a minute, write yourself a key idea, write it down here, something that you want to remember, and I'll see you in class.